This video will provide a brief explanation of global Moran's eye, which is used to assess spatial autocorrelation. Given a set of spatial features and an attribute stored on those features, this test assesses whether or not the values stored on the geographic features are clustered, random, or dispersed. The null hypothesis is that the pattern is random, or that no spatial autocorrelation is present. If a clustered pattern is suggested, this means that closer features tend to have more similar values. If dispersion is suggested, this means that near spatial features tend to have more dissimilar values. To experiment with this statistical test, we will use poverty data summarized on census tracts for the entire state of West Virginia. These data are provided by the United States Census. The census tracts are already symbolized based on poverty, with red indicating higher poverty rates. A visual assessment of these data tends to suggest clustering or spatial autocorrelation, as values do appear to be clustered. To confirm this suspicion, we can use global Moran's eye. This test is available in the Spatial Statistics toolbox and under Analyzing Patterns. It requires an input feature and an input field that holds the values for which we want to assess autocorrelation. Here we will use the field that holds the percent poverty rate. We will have the tool generate an HTML report of the results. There are several settings that can impact the test. First, we have to define how spatial relationships are defined or modeled. For now, we will use the default inverse distance method. Using inverse distance, nearby features will have a larger impact for the target feature than more distant features. We will also use Euclidean distance as opposed to Manhattan distance. Euclidean distance is the straight line distance between two locations. Once the tool executes, we can see that the result supports our assumption that the poverty rate is clustered for census tracts. Note that the Moran's eye index is positive and the p-value is 0. This indicates a strong clustering pattern. We failed to reject the null hypothesis that the pattern is random. If the Moran's eye index was negative, this would indicate a dispersed pattern. Let's re-execute the test using a different conceptualization of spatial relationships. This time let's use contiguity edges only. Using this setting, only features that share a boundary will be used in the calculation. The results still suggest clustering with a positive Moran's eye statistic and a p-value of 0. However, it should be noted that changing the settings may impact the outcome of the test. So it is important to think about what settings are used and if they are appropriate.